Hey you guys, here we have section 4.5. This is the first day of our last section of this chapter, and I'm going to kind of split it up into 2 days just because there's kind of a lot going on. What I want to draw your attention to is, first of all, there's a little bit of vocabulary that you can copy down. And what this section is, if you remember what I posted to my Instagram account was this pattern. And a lot of you were able to figure it out right away, but others of you didn't really recognize the pattern or notice that there was a pattern. This is an example of what is called a recursive sequence. What that means is that the first term and the second term, if you add these together, you get the third term. And then if you add the 1 and the 2 together, you get 3. If you add 2 and 3 together, you get 5. If you add 3 and 5 together, you get 8. Yes, you're adding, but keep in mind this does not make it an arithmetic sequence, because for an arithmetic sequence, remember, you have to add the same exact number every time, like +3 every time, or -5 every time. In this case, you are adding, but it's not the same number every time. This is called a recursive sequence because you're using the previous terms to figure out the next term. To figure out this one, you're using these two. To figure out this one, you're using these two. That's called a recursive formula, okay? And so that kind of will help explain maybe what some of these definitions are. But I'm going to do kind of as a warm-up the first 5 terms for each sequence. This is something that's pretty simple. All I like to do is I like to make this like sideways T-chart thing. And so what you do is for n, if you want to have the first 5 terms, I'm just plugging in the first term, second term, third term, fourth term, fifth term. Remember that n means term number. And so in order to figure out the first term, that's what a sub n, a sub 1 means, is the first term. All you do is you plug in 1 to the formula and you get 8. To figure out the second term in the sequence, you plug in 2 to the formula and you get 13. And so basically what this sequence is it starts with 8 being the first term, and then 13, and then 18, etc. Okay, so this is just defining a sequence, but plugging in 1, 2, 3, 4, and 5 to figure out what the term number is. A common expansion problem here would be find the 50th term. And nobody wants to list out 50 numbers, so obviously much faster to plug in 50 right here. And remember, that doesn't mean the 50th term is 50. That means when you plug in 50, the 50th spot way down here on our number line is going to be whatever happens when you plug in 50, a huge number. Okay? The second one, again, you're just given another formula here, so I'm going to make this sideways T-chart and label 1 through 5. Standing for the first term is -1. You're just plugging in the 1 for the n. And make sure that you do the exponent first and then multiply. Don't forget your order of operations. Exponents come before multiplication, so always take care of the exponent first and then times by the 3. Anyways, plug in 2 here, you get 4 times 3, which is 12, minus 4, which is 8. And this is our sequence here, the first 5 terms of a specific sequence defined by this formula. Okay, number 3, getting a little bit more challenging. So yeah, there are 2 different n's in this formula. So yeah, you're plugging in the n to both spots. Okay, and -1 to the first is -1. Keep in mind that's why I have a negative right here. And then when you plug in 1 right here, you get 3 minus 1, which is 2. So -2. If you plug in 2 here, the -1 pretty much goes away because it becomes a +1, and multiplying by +1 doesn't do anything. So plug in 2 right here and you get 6 minus 1, which is 5. So you're plugging in this n in both of the spots for the n and figuring out what the number is. So yeah, we are just, it looks like adding 3 every time, except the signs alternate. So isn't that kind of weird? Yeah, there are going to be different strategies, and it's a little bit mind-blowing that there's a lot of different ways to define some of these formulas. So you can start with 2, and then go to 5, and then go to 8, and then go to 11, and then go to 14. That's just adding 3 every time. However, the signs are alternating, and that's because we have this -1 to the n in front. So just keep in mind when you see a -1 to the n, sometimes you also see a -1 to the n plus 1. That's kind of the same situation. That's what makes your signs alternate. So there could be a specific pattern, and keep in mind you're not adding the same number every time because these signs are different. However, the signs are alternating because we've got this -1 to the n out in front. Okay. Let's look at another one. Another thing that I want to kind of give you a heads up for this section is that sometimes we can have formulas or patterns are such that make a formula on the top and a different formula on the bottom. And so that's okay. Basically, I'm still doing 1 through 5 and I'm plugging in the 1 to both ends here. So you get 1 on the top and 1 on the bottom, so that's just 1. When you plug in 2 here, you get 3, and you plug in 2 here, you get 8, so 3 over 8. What I want you to see if you can notice here, this is going to be a little bit mind-blowing too, but I'm going to change this into 1 over 1 for a second, just so you can help like see what the pattern is. But maybe if I didn't have this formula here and I just gave you the sequence, maybe it would be pretty simple to figure out what's happening. Look at the numerators, 1, 3, 5, 7, 9. That's a pretty simple formula to recognize, right? Ignoring all the denominators. That's an arithmetic sequence where you just add 2 every time. And you guys, we have a formula for that. You can figure out this if I didn't give it to you really easily for just the numerator. Another thing I want to point out is look at the denominators here. 1, 8, 27, 64, 125. That's not adding a certain number every time or multiplying by a certain number every time, but it is a specific pattern. I want you to think about cubes. 1 to the third is 1. 2 to the third is 8. 3 to the third is 27. Hint, hint, it was right here. But I want you to be able to pick apart fractions sometimes. A lot of times you can't tell if you look at the fraction as a whole what the pattern is, but if you look at strictly numerators versus denominators, it might be a little bit more recognizable. So just keep that trick in mind, okay? I way overcomplicated this question though, because the point of this question was just to find the first 5 terms. So all we did is we plugged in 1 here and here and got 1. And we plugged in 2 here and here and got 3/8. That was the only point. I just want to give you a little bit of a preview as to what else this section has in it. All right, so now we're going to get into something a little bit more challenging. Here is where we have a recursive sequence. So how do I figure out what the next term is if I know what the previous term is? And so here's a couple different things that I want you to think about. It wants me to find the next 4 terms, and they gave me the first term. Remember, this a sub 1, this notation means the first number in this sequence is 3. So this sequence has a 3, and I need to come up with the next 4. Okay, and it's also telling me n is greater than 1. So that's a little bit weird. That means that I'm going to start with n equals 2. Why didn't I start with like 1.1 or 1.5 or whatever? Because remember that n means term number. So we are not looking at decimals in this case. Decimals are irrelevant. There is no 1.3th term, right? There's only a first term, second term, third term, whatever. We're looking at integer values, positive integers. If n is greater than 1, that means n equals 2. So I have this weird looking formula. What this means is this term, the nth term, is defined by taking 4 times the previous term and adding 1 to it. So whatever the previous term is, which is a different number every single time, you multiply the previous term by 4 and add 1 to it. So all I'm going to do is I'm going to plug in 2 to this n and this n, because that's going to help me simplify what this question is asking me to do. So a sub 2 equals 4 times a sub 2 minus 1 is 1 plus 1. So all I did is I plugged in 2 here and here. 2 minus 1 is 1. Okay, and I know that this a sub 1 is 3. Plug that in right there. So that means that I'm going to get 4 times 3 plus 1, which is 13. That's the next term. Okay, so then I'm going to do the same thing with n equals 3, because that means third term. So that means a sub 3 equals 4 times a sub 2 plus 1. So again, all I did is I plugged in 3 for this n and this n. This is my formula up here, and this means I'm not using a sub 1, the first term, anymore. Now I'm using the second term. So what was the second term again? Second term was 13. When I do 4 times 13 plus 1, I get 53. That's the third term. Okay, and you can probably see the pattern. It should get a little bit quick, This is 4 times 3 plus 1. This is 4 times 13 plus 1. So the next one for n equals 4. That means 453 plus 1. I'm always just using the previous term, right? But multiplying it by 4 and adding 1 gives me 213. And then the last one, multiply 213 by 4 and add 1 to it. Gives me a pretty big number, 853. Can fill these in. 213, 853. Kind of weird, right? You're always using the previous term and multiplying it by 4 and adding 1 to it. That's exactly what this formula means. So you can write out every single step the way I did these, but if you recognize the pattern, I should label this n equals 5, then you can go ahead and work with the pattern, okay? You're always taking the previous term, multiplying it by 4, and adding 1, and that previous term changes every single time, okay? Let's try another one. Here we're given 2 pieces of information, and that's because this is like that Fibonacci sequence. That's what that 1, 1, 2, 3, 5, 8 thing at the very beginning of the notes is called, Fibonacci. He's a mathematician. Anyways, when you use the previous 2 terms, here's what a formula like that looks for. So let's say the third term is 2 times the first term minus the second term. Starting with n greater than 2, that means I'm going to do n equals 3 first. So I'm going to plug in 3 for all of the n's here. I have 3 n's I need to plug it into. So that means the third term, a sub 3, equals 2. A sub 3 minus 2 is 1. Minus a sub 3 minus 1 is 2. Okay? This is weird. That is why, because I have 2 unknowns, that they gave me all of this info. So the 2 goes here, 3 goes here. Let's see what this looks like. A sub 3 equals 2. What was that number? Times 2 minus 3, which is 1. That means the third term is 1. And what I'm going to do here, I'm going to write out my first couple terms. Started with 2, then 3, then I found 1, then I need this, then I need this. And it does ask for the next 4 terms, so that's why I'm putting 4 slots. Now let's do n equals 4. This one's a little bit confusing, so I recommend actually plugging in 4 to all the n's. That means A4. I'm plugging in the 4 here, here, and here into my original formula, okay? So a sub 4 equals 2 times a sub 2 minus a sub 3 when you plug in 4 for all the n's up there. So that's going to give me 2. What was the second term again? Second term is right here. That's what a sub 2 means. Second term is 3. And the third term was 1. So I got 5. Okay, let me try a couple more. What happens when I plug in n equals 5? That means I get the fifth term is 2 times a sub 3 minus a sub 4. So what was the a sub 3 again? The third term was 1. I'm going to plug in a 1 there. And a sub 4 is the fourth term, which is 5. Gives me negative 3. Pretty weird. Let's do one more. I'll do it in blue over here since I'm starting to get a little confusing. Actually, I'll do it in red. N equals 6. So again, all I'm doing here is I'm plugging in 6 for all of these n's. A sub 6, that means the sixth term, equals 2 times a to sub 4 minus a sub 5. So I'm plugging in 6 everywhere. So 2a4 minus a5. The fourth term is 5. Looking up at my pattern, the fifth term is negative 3. Careful with that double negative there because you're subtracting a negative 3, which means actually that you are adding. That gives me 13. Snap. That looks like a really weird pattern, but it's every single time using the previous 2 terms. And so let me zoom out so I can just kind of generalize the difference between these two. Both of these sequences, they were asking for the next 4 terms. In this sequence, they gave me the first one, so I put the first one here, and then I needed to find the next 4. In the second one, because it used previous 2 terms, this one only used 1 previous term, this one used 2 previous terms. That's why they had to give me the first and the second term. And so just remember that a sub 1, the notation for this section is really, really important that you understand. What most people get confused with is a lot of times they think a sub 1 is 1. But remember, a sub 1 just means the first term in the sequence. It's not 1 here, it happened to be 3. It's not 1 here, it happened to be 2. It did happen to be 1 here. In this one, it happened to be -2. So a lot of people just think that whatever the term number is what the term is. And that's very incorrect, so don't get those confused. A sub 1 means the first number is 2. So anyway, so what I did here is I started with my 3. And then since they told me to put n greater than 1, that means I'm starting by plugging in 2. And if you want to do this plugging in method, it'll work every single time. Start by plugging in 2 right here and right here. And that's how I got a sub 2. That means the second term. That does not mean the number 2. It means the second term. Equals 4 times the first term plus 1. And the first term here is 3. So I'm plugging in 3 for a sub 1 right here. And I got 13. So I just put that here in my second slot. To find the third term, again, I'm plugging in 3 for this n and for this n. And so I got a sub 3, which means the third term equals 4 times the second term plus 1. Well, the second term is 13, so that's why I plugged in 13 here. And then you can probably recognize the pattern here because we're only using the previous 1 term. This one is a little bit different, and it's much harder to recognize a pattern because you're using the previous 2 terms. But in this case, all you're doing is you're plugging in the previous term here to get the next term. Previous term, next term. Previous term, next term. Previous term, next term. And that's how I was able to get all 4 of these. This one was a little bit harder because it was using the previous 2 terms. So again, they gave me my first term and my second term, so start off by writing your sequence with 2 and 3. I need to find the next 4 terms, so I put 4 blanks there. They told me to start with n greater than 2, which means I'm starting with 3 here. And the easiest, simplest way to get started on this is just to plug in 3 here and here and here. Okay, so a sub 3, that means the third term, the number that goes in this spot, is defined by taking 2 times a sub 3 minus 2 is 1. That means the first term. So I'm going to plug in a 2 right there, which I did here. Minus, if I plug in 3 right here, that means a sub 2. That means the second term, which is 3. So I plugged in 3 here. That gave me 1, and I put that in my slot. I'm going to do the same thing with n equals 4. That means plug in 4 anywhere you see an n. So a sub 4 is 2 times a2, a sub 2, because 4 minus 2 is 2. Remember, that means second term. The second term is 3. That's why it's easy if you write it out like so. Minus a sub 4 minus 1 is 3. A sub 3, the third term happens to be 1, so put that 1 right here. 6 minus 1 is 5. Okay, so do the same thing for n equals 5 and n equals 6. You're just plugging in your terms and pulling those numbers from your sequence up here. And hopefully that makes sense, you guys. I am going to stop there, and I'm going to leave the rest for tomorrow's video. So hope you guys are hanging in there. Please reach out with any questions that you might have. That's a good intro for the rest of the notes that we're going to handle tomorrow. See you guys.